Okay, then we come up with the last speaker of the day. So it's P Moriniere from La Rochelle. And as always, he's going very deep into detail, talking about compute tomography on aquatic animals. Please, Pierre, go on.
Good afternoon, everybody. For the last presentation, we have only to look some images, very easy. So, with Dr. Marc Leger, a radiologist, we work on his initiative with a medical scanner to examine aquatic animals. He was curious to explore other animals and human bodies all the day. So we use a medical scanner, and a scanner is also called computed tomography. Is a test that uses X-rays, and its principle is to produce images in thin sections of a subject. And instead of being fixed, the X-ray tube rotates around the subject, cutting thickness of 0.60 millimeters. And the table comes into the tube for the acquisition of the scanner. So a photosensor converts radiation into digital information, and a powerful computer system processes the resulting images, which can be reconstructed as needed. For this, the radiologists have a medical diagnostic software, very strong, very powerful. And then we conducted post-image processing with Osiris. For these experiments, we used living animals collected at the La Rochelle Aquarium, and we transported them in buckets. We operate the night after the departure of patients, and we took care to handle animals without contaminating the scanner room or the examination table. And because of ions in seawater, seawater has a certain X-ray opacity, which is why for the duration of the acquisition, which lasts about 30 seconds, the animals are placed in the open air. So for some animals like Nautilus or jellyfish, we kept them in water. The first thing we see with X-ray is a calcareous skeleton here of an urchin, and we can have several, not only one section, but all the animals, and we can choose the image we want. Here sea star, and we can do several sort of images. And here we can see really the skeleton and the structure of the animal. And coming to the arms of the star, because the software can rebuild the organism and to calculate and rebuild and make new images. For example, we can have at different level of reading. So you see on the left the shell of the hermit crab, on the right the hermit crab himself inside. Here Nautilus, so we can see the body himself, but it's difficult and we would try to do better results on the Nautilus, because the better images we have is on the shell himself. When we read an X-ray images, in fact, we see different level of density. The density is measurement is done with Hounsfield unity and come from -1000 to +1000, and it can be, for example, sorry, I didn't look up. Here, the skeleton, we have 245 Hounsfield, and the air here we have -600. The fat is 47. The muscle is 44, and the liver is -43. So the different density give us the images, and we can read the density. And for example, here, Ciliarinus, we can see the liver here, the skeleton, and the olfactory sac here. On a porcupine fish, here we see all the body with the skeleton, the spine, and the swim bladder here, and we can choose to see more or less the spine of the swim bladder. Here, an hippocampus, and the same different levels. Here we can examine a sea bass, and we see the liver, the muscle part, the skeleton, and we can also see the brain and the cerebrospinal axe. We can look at Caretta caretta. All the animals were alive. And we can see the air part and les poumons. J'avais marqué les poumons. The lungs. So we can do a lot of images, and we can also use liquid contrast. So here liquid contrast can are liquid with iodine, which bring an opacity, and we here inject the liquid contrast into the digestive cavity of Aurelia aurita. And we also inject, like the liquid contrast is can be put with the food and to examine the digestive tracts or in the circulation. So we inject liquid contrast inside the circulation in the venous system of the sea bass, and we can show the venous system there. Sometimes there can be natural opacity. We find on the sea hair Aplysia fasciata, an opacity in the digestive gland. Here we can see the shell, which is very small on the sea hair, but here a very big part, which is the digestive gland, and which is 500 Hounsfield units, so very strong. We are working on this because it could be from the bromine, the accumulation of bromine is in this gland, so it could be interesting to know more about the sea hair and the opacity and of this gland and the production of this gland. We'll now look at a little video.